Okay, well, let me go ahead and clean some of this stuff up real quick. We don't need this. Lesson's over. Now, if you'll notice, this battery container, doesn't fit in to this tube very well, but it actually does in practice. So I need to actually redo this thing and factor in those filleted curves on it. Looks to me like just kind of eyeballing it here, like it's about a 1/4 inch fillet on those corners. So let me redraw this whole battery thing. Select the curve here and let's go to fillet curve. Okay, and it's set to 0.2. Let's set to 0.28. It's a little over 1/4 of an inch. Okay, now it's got our filleted curves. Now, extend this up to that. Okay, it's got our new solid. Go ahead and put that off to the side here. Let me go down here and go to material and hit match and select our old object, and then I can just go ahead and delete this thing. Yeah, I don't know if that's right on the right layer or not, so I'll change it. Okay, now that's a little better, but I still say, to my eye, it looks like we got, with a real device, it looks like we got more room than that. So, so I got to try to figure that out. It looks like we got plenty of room with the real object versus what I see here on CAD. I've adjusted the wall thickness. I actually went off camera and measured my inner diameter with my calipers and adjusted that tube a little bit, but still that's not enough to compensate for it. There is still the issue of it being 1.2 inch in one dimension versus 1.3. It could be that, let me try to measure, get a better idea. It's kind of hard to judge what the curvature of a fillet will be. I could make it say 300, a little over 300 mil. That might be a little more accurate. But I do know in one dimension it's oblong versus another, so let's take that into account as well. Because if you recall, one was 1.2 inch. In fact, let's do this exactly instead of approximately. It's 1.16 by 1.25 exactly. So okay, I was pressed undo several times is what I did, but let's make this well, I'm just going to redraw it. It'll be easier in this way. 1.162 by 1.252 exactly. I got a little bit of error there, but Okay, and I'm going to fillet this. Like I said, make it 0.31. It's roughly the diameter of a battery, I think, but the fillet might be a little different than that, though. Okay, now let's take this. Move it. Well, actually, I don't need to. Could just use the center, but. And then we'll extrude this out, and that's got us that, and then we'll move this thing out of the way. I'll delete that. Okay, again. Okay. Now it looks a lot more like the reality. So, again, that's why it pays to be accurate on some of this stuff. Sometimes you can, because I always like leaving tolerances for error in my design. I just always do by habit. And, but sometimes, you have to try to be a little more precise than that. And, this is one of those occasions. Because, that just wasn't matching up or lining up properly at all the way I had it. We weren't going to have any wall thicknesses to work with. And since I'm going to do a threaded wall on this, it's kind of important we have, thickness to work with. However, I could always make the base bigger than the base doesn't have to be the same diameter of this. I mean, it could actually flare out to a larger diameter on the bottom, so it's not really a huge problem. Just depends on what we end up doing about this diffuser, and will it slip around the battery or not. That I don't know yet. I mean, I'm still trying to make up my mind. You see, one of the issues that we have to work with is I got to put the electronics package somewhere, with the switches and all that stuff. We got to put that somewhere in here, and we want it to be below this lid. And this lid, we're going to have to actually have a little carrier for it, since we're not. I can't print in clear plastic, without it, in really transparent plastic. I can't 3D print and something that is clear like a window that you can see through. So we're kind of stuck with using a tube, so I'm going to have to make a little plastic carrier, kind of like I did on that 9-volt candle. It had a little hinge unit that the clear tube set on top of. In practice, that clear tube would actually be injection molded, out of like polycarbonate or something like that, with a hinge and everything included, so there wouldn't be any mounting involved. But to simulate that in 3D printing, I needed to actually print a carrier for it. That's what we're going to have to do on this. There's going to have to be a little carrier ring that has little guides on it, so that it can actually stay attached to this cylinder, that we're going to have here. So, but we're going to want the switches below this in its retracted position. So, that's why there's a lot of stuff we're going to have to research as we do this. So anyway,